questionable and you really don't know what you're doing, you need to kind of ask me a question, but ask me a question from your notes, from a homework problem, not from the quiz, but ask me a question that way we can go back over it. You've got to figure it out. There is going to be a quiz on Piecewise sometime next week. I mean, not quiz. We just quiz on it. Good, great words, English. There is a test that will include Piecewise next week, probably next Tuesday. Might be Wednesday, hoping Tuesday, but you know, my hopes can be dashed. So we're hoping Tuesday, but maybe next Wednesday. So, and Piecewise would make, we spent a lot of days on it. So, you know, Piecewise is going to be a major chunk of that test. So, yeah, you just blew a 30% grade. It was 50 points. Don't let it happen again with a 60% grade, because that's a 100.6% category. It's really going to hurt your average. Okay, let's go ahead and get out your notes, too. So we are back to that giant packet. We haven't spent a lot of time in it lately. It had the page 23 and 25 homework in it. That giant packet, get it back out. We're actually going to skip around in it today. Instead of going to the next lesson, 2-6, which is parent function, we're going to go out of order. We're going to go to a good confidence booster lesson, 2A. It'll make you feel better about your life. It's 2 from the end. And on the bottom page, it says 37. It's linear inequalities. Have a nice. Yeah, so if you turned in your homework and it was in that packet, I need to hand it back to you. After Grace is one of those. Okay. Okay, so, no, Drea, I don't have yours, it's just a page. You won't turn in the entire packet. There we go. Lyric.
What page?
37. It's 2 from the end. Everyone, here's yours. Okay, I think everyone else took it out of theirs. I don't fill in the other giant packet. Oh, I lied. Matthew. Yep.
Why these numbers? Why the last 3 numbers literally? It goes 30. Wait.
Oh, it's out of order. We'll talk about it. It's out of order. You know I'm not
31.
perfect. You know I'm not perfect.
33.
You're not surprised.
37.
Nobody. Yeah.
35. 38.
Yeah.
Where's 36?
I know. Okay. I'm not perfect. You know that. Okay, let's go ahead and go over these 3 math workshop problems. And then we'll go to our notes for today. Only 6 problems. Won't take us long. There's a checkpoint today. After we do the notes, there's a checkpoint on the topic. If you pass that checkpoint, then you don't have any homework tonight. If it takes you a while to pass that checkpoint, then that would be your homework tonight, is to finish that checkpoint. And let me go ahead, since you're already listening, because you're on it today. It would be what I'm going to call an all-by-myself checkpoint. Last 2 checkpoints have been like, oh my gosh, struggle's real, you can help your friend. This checkpoint is so, no offense, it's so easy. You should be able to do this all by myself and then be done and then turn it in. And so when you finish your checkpoint, come put it in a stack on my desk. It's going to take me a few minutes because people are going to finish that fast. I'm going to get that big of a stack that quickly. Come put it in a stack on my desk and I'll call you when I need you. Number 4, Travis, you had your hand up so early. Go ahead. 6 does go into 36 and 18, but there was a larger number. Drea. 18. So if we factor out, what did you factor out? 18 what? Okay, did you do 18x or negative 18x? Either one's fine. Okay, you did 18x, and what did you have left? Okay, that's perfect. So if we were to check her when we distribute, it would be negative 36x squared, positive 18x. She's completely correct. Her group can have a point. Travis is right. 6 does go into 36 and 18. 9 also goes into 36 and 18, but we want the biggest number, the greatest common factor. We're trying to factor out the biggest thing we can. So 18 is the correct idea. Grace.
8x to the 3rd.
Oh, she's already on the next one. Okay, hold on half a second, Grace. It is okay if you did negative 18x and you got this instead. That's also an acceptable answer. I would have done the top one, but understand in life, maybe they factored out a negative 18, so the bottom one is also feasible. Okay, and then Abby Grace is going ahead and answer in number 5. Say it again, ma'am.
8x to the 3rd.
My
Plus 2x minus 1.
plus 2x minus 1? Okay. Abby Grace and Brady, because I don't know which one of you, if she said it correctly or not, we're going to give Brady the point too. We'll both get a point for that. I'm halfway out of it this morning, so let's check it. 8x to the third, x to the sixth. We add our exponents. 3 plus 6 is 9. 8x to the ninth. Abby Grace is correct. 8 times 2 is 16. 3 plus 1 is 4, so 16x to the fourth. She's correct on that term. Last term, negative 1 times 8x to the third would be negative 8x to the third. So that is completely correct.
Love math.
Yay. And then number 6. Someone different? Someone different?
My answer.
Someone different? You can do it.
Me?
Yeah, you can. You're different. I mean, your
I didn't
group's
know
not
if you
different,
meant
but you're different.
Different group or different.
I meant different group, but you're acceptable.
Okay, 5x over parentheses x squared y squared plus 2xy plus 5.
That seems correct. Let's check it. If we distribute, we would have 5x to the third y squared. Yep. We would have 10x squared y. Yes. We would have 25x. Yes. So that is completely correct. He is correct with his factoring of pulling out the GCF. Okay, yes, you can have a point for that. If your group was trying to get a, yes, dear. That last term doesn't have a y.
I wanted to say that.
Okay, sorry, Xavier. I was in a hurry. If your group was trying to get ahead, you know you could do 7 through 12. That's going to be tomorrow's problem. So if your group went, you were looking for something to do, 7 through 12 would be genius. Okay, any questions about the ball ringer? Math workshop, sorry. That's the appropriate term.
Love math.
Yeah, we got it. You love math. You're super happy.
Really high today.
I know. Okay. Okay, we are going to graph linear inequalities today, which is actually going to be super easy. It's even easier than piecewise. I think it's much easier than piecewise. So first things first, we got to get our English right. It should be an inequality. It's page 37. It's 2 from the end. 2 from the end. Okay, an inequality. It resembles a linear equation, but with an inequality symbol instead of an equal symbol. With an inequality symbol instead of an equal symbol. I know everyone knows the answer, so I'm going to go with the first hand I see. What are the 4 different inequality symbols? What are the 4 different inequality symbols?
Yeah.
Oh, wait.
Go ahead.
Plus, minus, divide. Is that it?
That's the 4 different operations we use
Okay,
in math.
I got
Yes.
it. I got it. Is
Okay.
it a little arrow?
And we need English and math English.
The greater than, less than, greater than or equal to, less than or equal to.
Okay, good. You're going to have a point. Okay, so you know the inequality symbols, but no, it's a 1 point.
No, I'm talking about I've got 2 points. I can.
Oh, in your life. Oh, okay. I understand. So, yes, that's what's changing today. Instead of an equal to sign, we're going to have a greater than, a less than, etc. But we're actually going to graph it the same way we would graph if it was an equal to sign. So our first problem is negative 3x minus 2. If this was y equals mx plus b, our b would be negative 2. Our m would be negative 3 over 1. We agree with that? So just like that equation, that y equals mx plus b, it's in slope-intercept, we're going to graph it like normal. So I put my intercept at negative 2 on the y-axis. Let's say that again. Our intercept is negative 2, so I put a point at negative 2 on the y-axis. My slope is negative 3, so I go up 3, left 1, up 3, left 1, up 3, left 1. And I can do the same thing. I can go down 3, right 1, down 3, right 1. And if you're like me and you have to think this through, since it's a negative slope, my line leans to the left. I know I've done this correctly since my line is leaning to the left. Yes. So it would lean to the right if it was a positive. Yes. And then from here is where we start getting into what that inequality symbol was. So yes, you and I pretended it was a greater 2 symbol and we graphed it. Are there any questions about graphing it? We pretended it was a greater 2 symbol and an equal to symbol and we graphed it. But really it's a greater than or equal to. Okay? So just like what we just did with piecewise. With piecewise, if it was less than or greater than, you used an open circle. with graphing an inequality, if it's less than or greater than, we're going to use a dotted line. And just like with piecewise, when it was less than or equal to or greater than or equal to, we used a filled-in circle, a shaded circle. And with a less than or equal to or greater than or equal to, we're going to use a fully shaded line. Or a solid line. I should put solid. That'd be better term. Solid line. So what that means is, since our problem is an equal to, I'm literally going to connect those dots with a solid line like you wanted. But if it had been just a greater than, when I connected the dots, I would have done it with a dotted line. Okay, so let's back up. So we graphed this line. Since it was greater than or equal to, we used a fully solid line. But we're not technically done, because we're supposed to graph an inequality, and our inequality says greater than or equal to. So it's not just that line, it's stuff greater than that line too. So we're going to shade above that line, because our inequality said everything that's greater than or equal to. So we're going to shade above that line, because that's going to be the greater than. I'm going to do a test point in just a second. Do you have to be a perfectionist when you shade? Heck no. I do it real fast, real ugly, and move on. If Drea wants to take her time and color, she can. But all I'm looking for is a quick little, this is where it is, I'm done. Okay, Xavier.
Okay, won't wherever you shade end up being wherever the arrow's pointing 9 times out of 10? Or yes, no, okay.
I don't like to think of it that way, because then my life starts getting confusing. I think of it as, it was greater than, so that needs to be above the line, less than needs to be below my line. You'll see what I mean in just a minute when we get to number 4.
I think that, but I remember
getting confused.
Not last, it might have been last year, but when
2 years ago in algebra when you did this.
Yes, when there were multiple lines,
you got confused.
You only had to shade like a certain.
Where they overlapped. We're not going to do the overlapping ones yet. We're just going to do one.
Okay,
but yes, I understand what you're saying.
Okay,
so I get thrown off too. So let's talk about how to make sure I'm not crazy when I shade in. So this is it. This is the answer. We're done. But I like to make sure I'm completely correct. So I use a test point. Now, when I pick a test point, I pick a point from over here in our shaded region. For instance, an easy test point would be 0, 0. It's in our shaded region. It's to the right of the pink. So we can plug in 0, 0 into our inequality and see what happens. So our inequality was y is greater than or equal to negative 3x minus 2. I'm plugging in a 0 for y, a 0 for x. I end up with the statement 0 is greater than or equal to negative 2. Let me raise that up. So I decided to plug in 0, 0. So I plugged in 0 for both pieces, for x and y. I ended up with 0 is greater than or equal to negative 2. Is that a true statement?
Yeah.
Isn't 0 greater than or isn't it bigger than negative 2? Yeah. So if you plug in your test point from this shaded region and you end up with a true statement, you're not crazy. You did shade correctly. That's our goal. Like, yes, that's what I got. That's not a crazy statement. 0 is bigger than negative 2. So I did shade correctly. So if you start questioning yourself of, did I really shade correctly? Plug in a test point and see. We're going to plug in a test point on the next one. And then after that, I probably am not going to plug in a test point. And most people, when they bring me their checkpoints, they're not even going to plug in a test point either. So you have to know, but if you're questioning your sanity, it's really not a bad idea. Okay, are there any questions about number 1? Yes, dear. Ask it.
I feel like this is going to sound very self-explanatory. But okay, when you say plug in the test point, you mean, okay, quick question, because this is
I plug in a test point. No.
Oh.
Let me do the next one, and then I'll answer. I know exactly what your question is, and the answer is no, you don't have to pick one from the solution set.
No, I was going to say,
okay.
I'm sorry.
No.
I was going to say, if you, because I know that I do it, if you get confused on where to shade, then
I plug in a test point. If I get a true statement, yes, shade there. If you get something crazy like negative 5 is bigger than or equal to 10, that's crazy. So opposite side, yes.
Okay.
Yes, and that's exactly what I was going to say after. Yes, so we'll come back to that in just a sec. Okay, so let's go to the next one. It's x minus 5. To get your group an easy point, can you in English explain how to graph this line?
Yes.
Lyric, please do.
Okay, do we go down to negative 5?
On the Where?
On the y-axis.
Okay, I go down to -5. 1, 2, 3, 4, 5. So the hardest thing about today's notes is it's hard to read where the numbers are. So I do go down to -5 on that y-axis. Now what, ma'am?
So up 1 and over 1.
Okay. And what about to the left?
And then you go down 1 over.
Perfect. And Lyric, your group gets a point for that. Okay. Yes, she helped me grade. There's more available, though. Here's another easy point. It's, how do I do this line? And he said it so fast, we're going to give it to him. It's dotted because it's just a less than. So when I connect the dots, don't do them fully all the way. It needs to be a dotted looking thing or a dashed line. And the reason it's dashed is because equal to is not in our solution set. So seriously, that line is not part of the solution. That's why we dash it. That's our way of showing ourselves, P.S., that's not part of the solution. Okay, and then it was a less than. So we assume we're supposed to shade up or above or below. So where is below? Is this below or is this below?
That is below.
This is below. So let's shade down here.
Okay, I see why you said don't.
Oh yeah, don't. Yeah, I don't do that. I used to think that, and no, don't ever think it. Okay, so that's below. But again, we're questioning our sanity. We want to make sure we're 100% correct. It would be great to pick any point in this ugly brown shaded region to plug in as our test point. I like to pick test points on the X or Y axis because then I'm getting to plug in a 0 for somebody. So I think I'll plug in, what is this? 1, 2, 3, 4, 5, 6, 7, 0. I'll plug in 7, 0. So my test point, I'm selecting 7, 0. But seriously, Xavier can select any point in this brown shaded region, and when you plug it in, it should work, or else we've done something wrong. Okay, so our inequality was y is less than x minus 5. We're plugging in a 0 for y, a 7 for x. So we end up with the statement 0 is less than 2. Is 0 less than 2? Yeah. So we're happy we did shade correctly. Okay. Are there any questions about this? Okay, Miss Brister is with me first period. And, you know, different people think different ways. She does this differently than me. So for her test point, every single time, she uses the organ. Every single time. So, let's see if I can get both examples on the screen at once. Okay, let's talk about why she does that. She realizes the origin is part of the solution set with our first example, so she should get a true statement. She realized 0, 0 should not be part of our solution set in the second example, so she realizes she should get a false statement. So she's cool with getting something like -5 is bigger than 10. That's what she wanted. She wanted something crazy. For instance, if we plugged in 0, 0, we would end up with 0 is less than -5. 0 is not less than -5. So she did pick the correct region to shade because that was a crazy statement. 0, 0 was not supposed to be part of the solution set. So if you want to be like her and always use 0, 0, you can. Not a bad idea at all. Me, I like to know that, I don't know. I like to pick one from my shaded region and plug that in. Doesn't matter as long as you're thinking it through. Yes, dear. Go for it. No.
Okay, for a graph like where you would have a dotted line, what if it goes through the origin and you point and you use the origin as a test? So
okay, he has asked the best question I've heard all day, and his group can have a point for that because I haven't specified this all day long, and I need to. Did I pick a point on my pink line? When I picked my test point, did I pick a point for my pink line? No. Did I pick a point for my green line?
No.
I don't like to pick one that's actually on the line. Now, if it's an equal to one, you can, but I don't like to. I don't, because then you have to think through, was it dotted, was it shaded, did I mess that up? I just don't. I pick one from down and below, somewhere over here, not actually on the line, so I don't have to think through, was it really dotted, was it really sodded, am I crazy today? Apparently I am because I can't talk. Okay, number 3 is different. We can't graph from here. For another easy point, telling you an easy point day, what form does this look like it's in? Yes, dear?
Standard.
Looks like it's in standard. I heard it from 1 and 2, so both can have a point. I heard it. Two raised his hand. 1 couldn't help it, blurted it out. So 1 and 2 can both have a point. Okay, so it's yes, please. Please help me with that. That would make my life so much easier. Please do, Travis. Now what? Okay, so we want to get y by itself because we need it in y equals mx plus b to graph. So he's helping me rearrange the equation to get y by itself. Okay, subtract x. We've got 2y is greater than negative x plus 6. Now what? Divide by 2. And then what do you end up with, Travis, so I can give you that full point? Okay, so negative x over 2 plus 3. And he's correct, but that's not really helping me graph. So maybe it'd be better if we wrote it as y is greater than negative 1/2 x plus 3. Then you can say my intercept's at 3, my slope is negative 1/2. He's not incorrect, but again, we're trying to make our lives easier for graphing. So graphing purposes, maybe it's easier to write it like this, so you can say my slope is this, my intercept is this. Travis, you can have a point for that. You did a lot of work to get 1 point, but you can have a point for that. Yeah. All the things. Okay. So we're going to go up. He's going to have a chance for that in just a sec. So to graph this, we go up to 3. 1, 2, 3. We put our intercepts. Our slope is negative 1/2. We go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Up 1, left 2, up 1, left 2, left 2. Table 6, because you've been quiet and you need just some points.
Table 6?
Yes, you're not table 6. Table 6. You're quiet and you need you some points. Am I going to do a solid line or a dashed line? A dotted because it's just a greater than. Thank you. She's quiet, but she's smart. Okay, and then for another easy point in table 6, am I shading above or below this line? Above because it's greater than. So let's shade above. Okay, she seemed pretty confident. I'm pretty confident. You can have another point for that. I'm pretty confident about her response. And then we want to move on because you're understanding. But again, you could pick a test point from here. Check it out. Make sure you're not crazy. It's not a bad idea.
Yes, ma'am.
Okay. Miss Compton cannot copy and staple this many pages and not make a mistake. That seems rather obvious. So, we need to go to number 4. Number 4 is not this one problem that's got an absolute value. It's not that. And it's not the Chapter 2 study guide either. So I need you to find the page, probably the next page. It says x is greater than or equal to 6, and it's number 4. I need you to go to that one. Yes, it says 38 at the bottom, bless you, Brady. I apologize. You knew there was bound to be a mistake somewhere. Okay. Every group can get a point for this, and Brady is stinking already doing it. I don't know how he knows me this well, or he just wanted to answer the question. You just wanted to answer the question. You didn't even mean to do it. Okay. We're going to pretend that didn't happen then. Every group can get a point on number 4 if someone in the group is holding up their arm correctly for what this graph would look like on number 4.
Like if we hold up our arm in the correct angle?
Yes, but if you have people counteracting you, you see how we have an issue.
Hey, boom, Andrew's locked in. Hey, lock in. We're locked in. Table 1's locked in right here.
You give 6 offset access?
6, y'all got something to say? Okay. Let's say 2, 5, 4, and 3 can get a point. 1 and 6 is this.
Okay.
1 and 6 is this. Okay, so let's think it through, and if you're having trouble with that, trust me, I get confused on horizontal and vertical too, don't know why, it's just a thing. Okay, so if we're thinking this through, they say x is greater than or equal to 6, so we've got to find 6 on that x-axis. 1, 2, 3, 4, 5, 6. It kind of makes sense, in order to hit 6, let's zoom in order to hit 6 on that x-axis, in order to go through that point, wouldn't it have to be this kind of a line? Because if you held up this, yeah, you're hitting y equals 6, but you're never hitting x equals 6. X equals 6, we talked about it recently, it's technically not a function, but anyway, it would look like this because it's got to hit 6 on that x-axis. And Miss Compton's already stolen your joy, didn't even think about it. It was greater than or equal to, so I just innately did a solid line. My bad, no points for that, I did it myself. Point to myself. Point to myself. Okay, but another point is available. It is greater than or equal to. So do we shade to the left or do we shade to the right? This one's a little hard. Yes, dear.
Right.
And we are going to shade right, and Andrew's got his good point. If it's one like this, for the love, plug in a test point. Because this one is where you're like, I don't know what is above. You got to, for the love, use a test point in order to make sure you're not crazy. I'm loving 7-0 today. So for my test point, I'm going to use 7-0. But we're also going to come back and use 0-0 in just a second. Yes, dear.
Okay, I was going to ask you. Okay, I was going to ask if you.
Okay, so I'm going to use 7-0, but there are no y's. So I don't have anywhere to put the 0. But I do have somewhere to put the 7. It was x is greater than or equal to 6. Now I'm going to have 7 is greater than or equal to 6. Isn't that a true statement? Yeah, 7 is greater than or equal to 6, so I did shade correctly. I'm not crazy. Yay. Okay, again, you don't have to be my twin or my mini-me in life. Miss Brewster always uses 0-0. No matter what, no matter how she shades, she plugs in 0-0. Okay, so let's be like Miss Brewster. X is greater than or equal to 6. So is 0 greater than or equal to 6? No. So she's happy because she plugged in 0-0. It wasn't supposed to work. It wasn't part of where we shaded anyway. So she's happy that it failed because it wasn't supposed to work. So if you like her logic, you can always use 0-0 if you've got that understanding. Me, my brain is slow. I tend to just pick one from the shaded, but her way is sure easier. Okay, and then here, and Travis has been dying for the 2-point option. 2 points are available for this. If I have to explain my thoughts, then I'm going to reduce it to 1. 5 and 6 are more complicated because we're going to complicate our lives because inequalities are complicated. Something complicated happens with an inequality problem. It's about to happen. Do you know what that complicated something is? Do you know I've asked this question all day and you're the first person to answer it, especially answer that quickly? Your group gets 2 points. Okay, when do we have to flip the signs?
When you divide by negative.
When you multiply or divide by negative. So if you didn't remember that, you probably need to write yourself a note. Flip. Yes.
It's multiply or divide?
Yes. No, well, you and I, when we solve a problem, we always divide. But you and I both know, instead of dividing by -3, you could multiply by -1/3. So technically, it's multiply or divide.
Okay.
You and I are only going to divide. But technically, if you multiplied, let's say you multiplied everybody by -1, it works with it too.
Yes, I'm just saying.
No, I agree. I agree. We're only going to divide. He is correct. Okay, we need to flip the sign. I just did inequalities in discrete for other reasons. They do different things, but anyway. And I swear, I have this one kid who every single flipping problem, he flips the flipping sign. Every single problem, he flips the sign. He flips it, he flips it, he flips it. You only flip it if you multiply or divide by a negative. You only flip it then. Do not flip it otherwise. And we're going to go through an example of that now. And we're even going to talk about if Xavier makes a mistake, what that means happens to his graph. We're going to talk about it in just a second. Yes, dear?
I feel like I'm asking a lot of questions.
You're not. It's good.
Okay, what happens if... What's my question?
You flip it and you weren't supposed to?
No, it wasn't that. It was... Oh, what's like the mathematical reason that you flip the sign when you divide by negative?
Why?
You're switching all of the values from a positive to a negative.
There's exactly. Oh my God, Brady, you can have a point for that. Technically, you're like you said, you're flipping all the values from a positive to a negative. Everybody that was positive is now negative. So everyone that was greater than is now less than. So it makes sense that you have to flip the sign because you're changing everyone's sign.
Okay.
Since you're changing everyone's sign, people who were greater than are now less than, so it makes sense that you have to flip the sign. But do people think it through like that? No. Do they flip the sign really willy-nilly? Heck yes. Okay, I've got an easy point available, especially for my super quiet group. Would you like to help me rearrange this equation into y equals mx plus b? I got like 5,000 other volunteers if you don't want to. Do what? Say it again. Yes. Gosh, she's good. Okay, so you and I both know we subtract 4x. Let's see if we get what she gets. So we've got negative 3y is greater than negative 4x plus 12. Everyone good with this? Okay, now she said from here, she got 4 over 3x plus 12. There's something wrong in that statement, and she's going to fix it. She's going to fix it. She's stinking got this. She's going to fix it. The 4 over 3x is correct. What's wrong about 12? What should it be instead? She's got this. Leave her alone. Yes? Yes. Should be negative 4. Yes. And you can have your point for that. Okay, so we divided by negative 3. We've got y, and then yes, negative 4 over negative 3 is positive 4/3. Every single person, not every single person, that's like over-exaggerating, but there were a lot last period who, yes, the checkpoint question, of course you knew I was going to put the negative one on there. And they did negative divided by a negative, and they got a negative again. Shouldn't negative 4 divided by a negative 3 be a positive 4/3 x?
Yeah.
Okay, and then 12 divided by negative 3 is negative 4. But the most important part of this problem is to flip that sign. Since we divided by a negative 3, we must flip that sign from a greater than to a less than. You have to have done that. And we'll talk about what happens if you didn't in just a moment. Yes, dear?
I just want to point out, even if you forget somehow to remove the negative symbol, if you have like negative 4 over negative 3, the graph will still look the same.
Yes, it would. But they didn't do that. They still did negative 4/3. Don't know why. Or it's a different fraction. Yeah, they still did the same. Yes, dear?
So I just added 3y.
You added 3y and then subtracted 12 and moved it all over. You need to beware doing that. Here is why. In fact, Travis, I'm not going to say it out loud. When I get done rambling and everyone else says their checkpoint, come see me and I'll show you why. Because otherwise, I'm going to confuse the bejesus out of everyone else in the room. I can see me trying to do that now.
And I come see you too, because
Yeah.
I was just going to do that.
Yeah. In fact, maybe I can say it out loud, and those who get me, and those who don't, just it's okay. Just don't cry about it. You got this. You totally got this. If you end up putting y on the right side instead of on the left side, then technically you're going to end up with the statement like, for instance, if this was a much easier problem, you would end up with like 3 is greater than y, and then you're like, I can't graph that. I need to rearrange that. It would actually read y is less than 3, so you end up having to read it backwards. You're making your life more complicated when you move y to the right side, because at the end you're having to read the inequality backwards.
What I did was I literally swapped it and changed it.
If you understand to do that in your head the way I did there, because it basically just flops it, then that's great and you're going to be fine. But then that's what was going wrong with my kid in discrete. He's trying to flip it for the dividing. He's trying to flip it here. He did like 5 flips. I don't know. So you can see why that no. He never said anything. Okay, yes, Will. Yes. Okay, so me and Travis we got on a different ramp. We're going to let that go. Okay, so we go down to negative 4. We put our point. Our slope is 4/3. So we go up 4 over 3. Up 4 over 3. Up 4 over 3. And then down 4, left 3. 1, 2, 3, 4. 1, 2, 3. Whew. And then since it's just a less than, I'm only going to use a dotted line. Okay. It's a less than problem. Where do I shade? Say it. She said it. She just didn't say it out loud. I'm going to give table 1 the point, but I'm also going to give 6 the point because she mouthed the word. She just didn't say it out loud. Okay, we are going to shade below. Okay, if Sarah's having a blind day, she divided by a negative and she did not flip the sign, she would have shaded above instead of below. So technically, she shaded the wrong part. She's got the wrong solution set. She's messed up the whole thing. So just be very careful, because if you forget to flip, you're going to shade the wrong region. Okay, are there any questions about number 5? Okay, we're going to do, yes, dear?
I was ready for number 6.
Okay, we're going to do number 6, and then it's your checkpoint. We're going to fly through 6. You're going to be super excited. You want to solve it for me?
I can tell you.
Perfect. Tell me.
The answer y is less than or equal to -3/2 minus 6.
I'm betting you're right. Let's see. 4y less than or equal to -6x minus 24. Because I've subtracted that. You divide by 4. I've got y is less than or equal to -3/2x minus 6. It is correct. Your group does get the point. Okay. He is a genius because, one, he did that super fast. Yes, you subtract 6x. Yes, you divide by 4. Yes, 6/4 reduces to 3/2. 24/4 is -6. He is super fast. He did it fast. We agree. That was a little ridiculous. But he's also a genius for another reason. Can someone explain why else he is a genius?
He simplified.
He didn't flip the sign. He didn't flip the sign. Was he supposed to flip the sign? No. Did he divide by a negative on both sides? No. But do you know, a lot of people, when they see that -6/4, they think, since they're dealing with negatives on the right side, that they need to flip the sign. So a lot of people in this problem would prematurely flip the sign, even though they didn't divide by a negative number. It's a little crazy, a little deep. Table 2, you get another point. Okay, so we go down to -6. 1, 2, 3, 4, 5, 6. Our slope is -3/2, so up 3/2, up 3/2, up 3/2, 1, 2, 3/2, down 3, right 2. Okay, it is an equal to, so Drea said it so fast, not even funny. Drea gets it, it's solid. Although you were the second I heard, I'm not going to lie. But you just got another point, so we're going to let it go. Okay, so yes, it is a solid line, but it is less than or equal to, so where do I shade? Quiet, quiet, quiet one. Where do I shade? Only I know I'm talking to you. It's okay if you mess it up. Say it.
We can do it. Let's go.
Yes, and we're going to shade below. And that's how your group gets another point. Brave one. Okay, yes. It's less than with shade below. If she's not sure, she's going to plug in a test point. Okay. Are there any questions about this? Now, somehow, y'all are geniuses because you've asked enough questions that you don't have as much time as the other classes had. I still think you'll finish rather quickly because you're rather smart. It is only one question. Let me go ahead and hand it out. If you finish early and you're looking for something to do, I know me and Miss Blackman, because she's SGA sponsor, she would appreciate if you colored one of the coloring pages I have on the school